Continuing our discussion on this knapsack problem, the previous session we have seen that the common knapsack problem, when try to work with backtracking and a lot of problems, it's going to be too costly to implement. But yes, there's another type of knapsack problem where the item can be either totally used or not used at all. So that's a decision problem, that is decide whether the item is to be used or not to be used. So this is a simpler one. So we call this type of problem as 0-1 knapsack problem, either use it or don't use it. In such cases, the other three methods are useful. So first let us start using backtracking method, how this can be helpful in solving the problem. It is 0-1 knapsack. So 0-1 knapsack. So let's continue with our old example so that it becomes easier to understand the situation and make up. So there are four objects, four items, and the profits of items are shown in the vector P, and the weights of the four items shown in the vector W, and the capacity of the knapsack is 40. Okay, let's begin one by one. And one good news is that you don't have to find the ratio, arrange them in descending order and all that, as we did in the greedy method. Here you don't have to worry. So use this in any combination, it's confirmed to give the result. Okay. So first we start building a tree, and because it is 0-1, so either use it or don't use it. Therefore the tree is a binary tree. So the first node, the root, we begin, and at that time no item was put in the knapsack, therefore the knapsack is totally empty. So the capacity to be filled is still 40 and nothing is there. So the total profit out of items in the knapsack is going to be 0. So first thing is think about the first item. So if x1 equal to 1, so use first item. Then the capacity of the knapsack was 40. The weight of the first item is also 40, so it fits perfectly. So nothing is left in the knapsack for there to add anything extra. So the total profit made is 280. Then we can't proceed any further because nothing is left in the knapsack. Then we go to the other side. So what happens if first item is not used? So if first item is not used, we go to node number 3, and here we look what if second item is added to the knapsack. So when you come to node 3, yes, nothing is added, therefore the capacity of the knapsack is still full. So that's all 40 is still available, nothing is added, so the total profit from the knapsack is still 0. So we add the second item whose weight is 10. So now the still empty space left for adding new things is of 30 weight, and the second item is of profit 100. So 30/100. Then try to add the third item. So when you try to add third item has got a weight of 20, and knapsack is still having capacity to add 30. So 20 can be added, no issue. And then we are still left with 10 more. So after adding the third item, so 100 plus 120, so the total is 220. And try to add fourth item. Fourth item is of size 24, and we are left with only 10. Therefore fourth item cannot be added in this part. So once you reach the dead end, then go back try other way, that is if you don't want to use fourth item, what would happen. So same 220 continues. So that's the end of it. Then come back to node 5. Nothing can be further extended down. Therefore, go back to node 4. Then look what happens if third item is not included. Then we come to node 7 and there think what happens if node 4, item 4 is added. So if item 4 is added, so out of 30, 24 has gone, 6 more is possible, and another 120 gets added to 100, so that makes 220. So other option is node 4 at node 7, x4 is 0, that means fourth item not included, so this 30 continues as it is. Nothing to continue, so move back to 7, move back to 4, then move to 3. Then we have one more option left, that is if second item is not used, what would happen. So we come to node 10, and earlier this is 40, 0, so it says 40, 0 because nothing is added to that. Then try to add third item, then when you add third item, we are left with 20, and the total thing is 120 profit. Then try to add fourth item, we are left with only 20, but fourth item's weight is 24, therefore it cannot be added. Back, come forward, if x4 is not used, item 4 is not used, then we are left with 120. Then back to node 11, then back to node 10, then we have one more option, x3 equal to 0, then x4 equal to 1 will get you 16, 120, so that gets 120. You can't add because already we have reached x4. Then come back, and if you make x4 0, then x1 0, x2 0, x3 0, x4 0, that means still capacity is 40 but nothing added to it, so this is 0. So in all, if you look at it, this leaf is at profit 0, profit 120, profit 120, this one profit 120, this is 100, this is 220, this is 220, this is 220, and this one is 280. So in all the leaves, if you look at it, 280 happens to be the best one. Therefore, the 0-1 knapsack problem says just use first item and make all others. And the total profit you can make is just 280. Whereas in the previous case, we had seen the other way, and it was able to give us profit of 310, but now it is only 280 possible because you have to use either totally or not to use. So that's a 0-1 knapsack problem, and here we work with backtracking. So that's depth first search logic, then get in till no further thing is possible, then come back, continue, come back, continue. So keep getting deeper and deeper inside till you reach the leaves. So that's it for now. That's backtracking way of solving this problem, 0-1 knapsack problem, that is a decision problem. The same problem can be solved either by dynamic programming or by branch and bound also. We'll see them in coming sessions, so keep watching. So if you like this, please don't forget to hit the like button, and please subscribe to this channel and push the bell button so that the upcoming videos you get the information about that. And please, if you like these videos, make sure to tell to your friends to view and subscribe. Thank you.